Hello, and welcome to the wonderful world of mathematics. I'm your host, Miss B. Today we'll be talking about two-dimensional figures, and our aim will be to derive the formulas for area of some basic polygons. To start, we're going to name the following polygons and list some properties of each. So here's the first. Its name is, of course you know already, the triangle. Alright, its properties is just that it is a three-sided polygon. It's got three angles and three sides. The next figure you see here, of course you know already, it's the rectangle. A rectangle is a four-sided polygon. Now, fancier than that is quadrilateral. A quadrilateral is a four-sided polygon. Quad means four. So we're going to use that word today. Opposite sides of a rectangle are parallel, meaning they will never touch. And by opposite sides, I mean the sides that don't touch themselves. So like right here and right here, those would be opposite sides and they're parallel. And right here, opposite sides parallel. Opposite sides are also equal in length. And we have four right angles. Now, this figure here is just like a rectangle, except it has a special property to it. It's called a square. And in a square, what's going to happen is all four sides will be congruent. They'll be equal in length. So we've got the four-sided polygons, quadrilateral. Opposite sides are parallel, just like the rectangle. All sides are equal in length, and again, it has four right angles. All right, so those are some you should have known already, the triangle, the rectangle, the square. Now, fancier, we get to this figure. All right, give you a second to think about what this figure is. It's kind of like a slanted rectangle, right? So the difference between this and the rectangle is that there are no right angles. We call this a parallelogram, okay? A parallelogram is a quadrilateral. Opposite sides are parallel, and opposite sides are equal in length. So rectangle is more specific. A rectangle is a parallelogram. It has the same exact things, except the rectangle is going to have the 90-degree angles, all right? Now this figure here is just like a parallelogram. It's also just like a square in some aspects because it's a parallelogram with equal side lengths, all right? So it's called a rhombus. In a rhombus, it's a quadrilateral, opposite sides are parallel, and all sides are equal in length. Again, but there's no 90 degrees, so a square is a little bit more specific. Now here, we have the trapezoid. The trapezoid, you could see, has some properties of the rectangle, some properties of the parallelogram, okay? So what's happening on a trapezoid is that it is a quadrilateral, again, it's four-sided, all right? But there's only two sides that are parallel. Okay, well, yeah, so one pair of parallel sides. So this side is parallel to this side. The other pair, they're not parallel, okay? They would intersect if we were to extend them. All right, moving on to the main event. What is area? Area, dun, 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 is the measure of the interior surface of a closed region or figure. All right, so your next question should be, okay, so who cares about area? When would we use it? All right, in the real world. So we've got some pictures here. Some of them are a little boring. Just give me some time. All right, so first, you would need to calculate area if you were going to buy bags of seed for your lawn, okay? You would need to know how much seed to buy. You don't want to overbuy and spend so much money on seed. Who wants to spend so much money on seed? And you don't want to underbuy and then have like patchy parts on your lawn. That would be crazy. So that would be one way to calculate area, one reason to do it. Now we have here people tiling the floor. Oh, they're all adults. They're so old. They do these things. All right. You have to measure your floor to figure out how much tiling you need to buy. Tiling's really expensive, so you don't want to buy too much of it. And of course, again, you don't want any gaps or anything like that. So you really want to calculate and measure correctly. All right. Then this girl, she's like super excited to be painting a wall. I don't know who's this excited to paint a wall. But, all right, again, you're going to need to know the area of the wall in order to figure out how many gallons of paint to buy. All right. So again, this is a reason to calculate area. As you can see, it's really about whenever you cover something, right? Whenever you're covering something, doing any kind of surface, you're going to be talking about area. And last but not least, in fashion, they use area a lot when they talk about how many yards of material to buy. That's definitely going to be something that they're going to measure. All right, so moving on. We've got the rectangle. The rectangle is a four-sided polygon containing all right angles. All right, you should know the area of a rectangle formula already, but I'm just going to go through it because it's going to help us figure out other things. So here's a rectangle. It's got a width and a length. It's got two dimensions. That's why it's called a two-dimensional figure, by the way. All right, because there's only two things we're talking about, this up and down dimension and this left and right dimension here. So the width, we're going to call it something else today. It's interchangeable. We're going to call it the height. And the length, we're going to call it the base. All right, height and base, same thing like length and width. So don't get confused. Now let's go deeper into the rectangle. I know you know the formula, but where did the formula come from? So go deeper, deeper, deeper. Wow! All right, so if we cut the rectangle into these tiny little square units, we're going to be able to figure out how many squares does it take to cover the rectangle, how many little square units. And that's basically all area is. So we've got 1, 2, 3, 4, 5 units across this figure. All right. And I've got 1, 2, 3 units as the height of this figure. And if I want to figure out how many little square units cover this, by the way, square units, that's what we say when we're doing area, because we're talking about how many squares can cover the surface. So square units, make sure you guys know that. Boop, 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 doo, 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 doo. All right. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 square units cover this rectangle. All right? 15 square units. Now, you're not going to do that to your wall. I mean, look at the wall of the room you're in. Do you want to make little squares on the wall and then count them to figure out how many squares it is? It would be ridiculous, okay? And then you would have to decide what you're going to do, if you're going to do square inches or square feet or square yards, and it just gets crazy. So what we're going to do instead, we're going to figure out a formula where we could just measure two things and get it quickly. So if you could just measure how tall your wall is, right? 3 for this little tiny wall. And 3 what? I don't know. 3 feet, 3 yards, 3 miles. Oh, that would be a really big wall. All right. And then we would measure how wide it is, or the base of the wall, all right, along the bottom of the wall. We would see that it's 5. What can we do to 3 and 5 to make 15? How can we figure out how many squares make up the inside, right? You would know, multiply. You multiply the height and the base. That's where we get the formula. So for all of those of you who knew, oh, area of a rectangle is length times width, very good. But did you know where it came from? All right, and we're going to call it this lesson base times height. It's the same thing as width times length or length times width. Do not get confused. Notice again, base times height or height times base, commutative property. The order will not matter how you multiply them. All right, so we're going to move on to the next figure. The square. All right, a square is a 4-sided polygon. Oh, look at him. He's so happy to be a square. All right, containing all right angles and equal side lengths. Now, a square is just a rectangle, isn't it? Except all sides are equal. So how could the formula be different? It's going to be a little different. We can figure this out by doing height times base. Let's go deeper into the square. Whoa! All right, so this square in particular is 3 units across and 3 units down. So if I wanted to figure out the area of this without having to count, I would just do 3 times 3. And I would get 9. And you can verify that by counting 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. So just write this. I could just write SQ for square, especially since writing on this is really difficult. I don't think you guys know how difficult this is. It's crazy. All right. But it's going to be more specific, because remember, these things are variables. H and B, they're variables. They stand for whatever number you're going to put in. But if it's a square, whatever number I put in for height, it's the same number I'm going to put in for base. So I don't really need 2 different letters to represent this. So what we do is we usually represent the height as an S and the base as an S. For side, side and side, they're the same exact length. So let's think about how the formula can be different. All right, so we had before base times height, right? Base times height was our area. But we don't need 2 different letters. So we decided to use the letter S instead to represent side. So really it would be side times side, just like 3 times 3. Can I multiply the same variable by itself? If I multiply a variable by itself or multiply a number by itself, we can put it together and then put the exponent of how many we have. There's 2 s's, so I do an exponent of 2. I'm multiplying 2 s's together, exponent of 2, s squared. Now that should make sense to you. If I did 3 times 3, can't I say 3 squared? Isn't 3 squared 9? So it's the same exact thing. So our area of a square is side squared. All right, very good, guys. You guys are doing awesome. Make sure you're filling out the sheet as we go along so that your homework is done. The next figure is going to be the parallelogram. Okay, I don't know what happened here. Let's fix this. That bothers me. All right, fix a little bit more. Oop, there we go. All right, so here's the parallelogram. This guy's a little funky. All right, a four-sided polygon with opposite sides being parallel. All right, so parallelogram. Here's what's weird. I didn't talk about height yet. Height or altitude, okay, those words are interchangeable. It's a line segment or its length drawn from a vertex perpendicular. Perpendicular means forming a 90-degree angle to the line containing the opposite side. Okay, so where is the height here? We have to start from like a point. So that's what a vertex is. We have to start from a point. We have to go straight down, making a 90-degree angle with the opposite side. So I can draw it here. I can draw it here. I could draw it here, and then we actually draw it because I don't know if all of you can see what I'm doing here. So I can draw one like this, all right? And it has to touch the opposite side. Now, obviously it doesn't touch, but remember, we could always extend this because all we're doing is we're measuring from here to here how tall it is, right? So if you were being measured, we would go straight up and down. So that would be the height right here, all right? You could also draw this height inside the figure. How about I move it? I could put it right here. Okay, again, it's touching a vertex. So the vertex is like a corner right there. All right, I can draw it here. Vertex to the opposite side. See, it touches the opposite side. It's making a 90-degree angle. And right over here is another one. Okay, so those are all the heights. Now, I'm just going to delete that for you. So now let's go deeper into this parallelogram. Here's what I'm going to do. Boom. I drew the height. Now, what I want to do, and what we're going to do this lesson, what we're going to do for almost every other shape, is we're going to turn the shapes into something we know. And in that way, we're going to be able to figure out the formula. So we can see here it's hard to make squares out of this because they're all slanty. So what I can do is I can cut this little triangle off right here. If I cut it off, and if I had it split up, it would take the same amount of squares, okay, to figure out what was inside. It's still the same amount of squares that we would use. We just cut a piece off. And what I'm going to do is I'm going to move this all the way over here. Okay? So now that it's moved over here, what shape do you see? It's not a parallelogram anymore. Well, it is still a parallelogram, but it's a specific one. It's the rectangle. It is the rectangle, and we know the formula for the area of a rectangle. It's base times height. All right? So that's what we get right away. So base times height works for a parallelogram too. The only difference is the height is going to be in a weird place. So you just have to make sure you find the proper measurement for height. All right? It's not going to be this line segment. It's not going to be that. Okay? It's too slanted. We want to go straight up and down. So it's always going to be the straight up and down 90-degree angle with the base. All right? Height is always 90 degrees to the base. All right? So the next parallelogram. Oh, not the next parallelogram. I'm sorry. The next figure is the triangle. Woo! Happy triangle. Yeah. All right. So here we go. Here's a triangle. Triangle's going to be funky. I'm not going to tell you the area formula for this one. No. I'm not giving that away. It's a secret. All right. You guys are going to come up with it. So here's a triangle. It's got a height. It's got a base. Again, two-dimensional. But I don't know how to make squares in here. That's going to be weird to like cut this into little squares. Very, very, very difficult. So how can I figure out how many squares are inside this? I don't know. So maybe cutting something off, but if I cut something off, I have to put it to make it something. I don't know about cutting things off. What do you guys think? Double it? How is doubling it gonna work? All right, fine, double it. All right, so then, I mean, now I just got two triangles. Now I've got more problems. You guys just gave me more problems to work with. Freaking, I don't know what to do with this. How can I fit this so that I can make something, turn it around? Okay, all right, let's turn it around. Here we go. All right, now, yeah, you guys just made some weird shape. I don't even know what this is. What are you guys doing? All right, this over here. No, oh, turn it some more. All right, turn it some more. Sure. Okay, so then what? Oh my goodness. La na na na, da na da na. Ooh ooh ooh. Rectangle. Yeah, there's a rectangle. All right, so I got a rectangle. Okay. Oh, base times height makes a rectangle. Awesome. All right, but how does that help me? Let's pretend that the base was 10 units long, and then the height was 5. That would make the whole area 50. but I don't want to cover this whole rectangle. I just want to cover the triangle. So how can I do that? So if I only want this piece. There's two of them. If I only want half of this rectangle, how can I change the formula? I'm not going to tell you. All right, but here's what I will do. I'll give you some hints. I'll help you. The area of this triangle right here is made from the area of the rectangle, base times height. But it's not the whole thing. It's not the whole thing. So I have base times height and I want to fix it. What do I have to do? So I want you guys to think about that. Write it down on your sheet, your ideas, and we'll see if they work tomorrow. All right, next. What? The triangle again, you crazy guy. All right, here he is again, but notice this triangle is not what we had before. This triangle that we first started with was a right triangle. It had a 90-degree angle, which made the height one of the sides. But we may have a triangle where the height is not represented by one of the sides because we don't have a 90-degree angle. So where is the height in this figure? Again, remember our trick. We can always draw a height by going to a vertex like this, extending it down to touch the other side. And we have to measure, we have to extend this. And it would be this measurement from the tip all the way down to where it hits the side. Okay? And we could change that. So let me just shrink it a little bit so we can move it around and see where else this height would be. All right? Could always draw it somewhere else. We could always draw it here if we wanted to and extend this side. That would be gross. Okay? And we could also put it in the middle. Let me show you. Again, it has to form a 90 degrees. So that's not 90. That's not 90. That's about 90. And we would have to measure it. We'd have to use a protractor, everything. So I'm just eyeballing it right now. And we could find this measurement. Now remember, if I call this the height, then where is the base? Is this the base? No. The base would then be over here. So where you draw the height, remember it has to connect to the base and form a 90-degree angle. So I'm going to use this height here, only because I want to use this side as my base. So hold on. Let's just throw this in there, making sure I got it. There we go. All right, so here's my height. Da-dum, dun, dun, da-dum. Height. Okay, now I'm going to perform the same magical trick. I'm going to double it. Boop, boop. I'm going to flip it around. Toot, toot. And then I'm going to make, holy molies, it's a parallelogram. All right, and you guys know the area of a parallelogram. It's base times height. But again, goodness sakes, we cannot just do base times height because that'll give us this whole big area. And we don't want this whole big area. We only want half the area. All right, there's a little hint for you. So let's see if you guys could figure out the area formula of a triangle. Okay, we're going to write that down. It's going to be the same one. Trapezoid. We got two of them because they're just so extra special. I love my trapezoids. Okay, so trapezoid's four-sided polygon with one pair of parallel sides, which are called the bases. All right, so here we go. Here's our parallelogram. Our trapezoid, I'm sorry. Here's a trapezoid. Notice now it has two bases. That's kind of weird. All right, so the parallel sides we have here. Here's base 1 and base 2. I'm going to perform another magical trick. I'm going to again double. I'm going to try to make a shape I know already. So, not a shape I know. Ooh, that looks like a dress. Okay, not a shape I know. Again, looks like a dress. Not a shape I know. I don't even know what that is. All right, let's try to turn it a little bit. Boom, boom. Let's see. No, no, no. And this is what people did. This is how they figured out formulas. Nobody, there wasn't textbooks telling them the formulas. They played with them. All right, so what about this? Aha! Look at what I just made. I made a parallelogram. All right, so in making this parallelogram, obviously I don't want this whole big area, but this might help me figure out this smaller area. All right, again, I have a height. It's perpendicular to the base. All right, and what can I do? This measurement, remember, was this measurement here. So let me just put it there. All right, there it is. Beautiful. All right. Now, the area of a parallelogram is base times height. But this parallelogram is huge. Look at this parallelogram. We've got this whole base here, whatever number this is. Let's give it a number so that way we can make more sense. Let's give it a number like 10. Okay, I'm making this up. Making it up. All right, and let's call this base over here 5. Okay, so what would be the total base of the whole parallelogram? It'd be the 10 plus 5, right? 10 plus 5 would be 15. All right, and then we've got a height here. Let's call the height, I don't know, let's call it 7. Does that sound good to you? Sounds good to me. I'm going to make it 7. I'm making it up. All right, so if I wanted to find this whole parallelogram, I would do 10 plus 5, which is 15, and I would multiply by 7, and that would give me the total area. But I don't want the total area. I just want this area. So how can I fix it? So I just have this one. All right, what would I have to do? So once I found the total area, so let's do that one more time. Okay, the total base, which would be 10 plus 5, I would multiply by the height, 7. That would give me this big area. I only want this piece. It's half, right? So what would I have to do? What would that formula look like? I'm not telling you. I want you guys to do it. So write it down. Try to come up with an idea of the area of a trapezoid. Give you the hint. It's going to use base 1. It's going to use base 2. It's going to use height. Okay? It's going to use something else too. I'm not going to tell you. Now, one thing I have to say, please make sure you understand. The bases of a parallelogram could never be, never be the non-parallel sides. So, for instance, this side here, this side right there, and this side right here will never be a base. The bases are always the parallel sides. So I don't care how they give you the figure, if they turn it around, if they slant it at you, I don't care how they give it to you. Please know that the bases are always going to be the parallel sides. The sides that are parallel to each other will be your base 1 and your base 2. They are interchangeable because we are adding them together, right? 10 plus 5, 5 plus 10, really doesn't matter which one we do. All right, commutative property comes into play again. All right, now I think that's the end. So we're going to sum it up, B. Here we go. Oh, and look at all these shapes that we make. We're going to be doing this at the end of the year. All right, what is the difference between a parallelogram and a trapezoid? Let's see if you can figure that out. Anybody? Anybody? I'm not telling you. You tell me tomorrow. How did we derive the formulas for all the polygons we discussed today, right? We cut them up. We cut them up into shapes we knew. The height of a figure must be blank to the base. The height of a figure must be perpendicular to the base. It has to form that 90-degree angle. All right? And your homework, I want to see that you do it, was to watch this video and to complete sheet 1201. And tomorrow we're going to actually practice using the formulas that you guys came up with yourselves. All right? Really proud of everybody who watched this. Can't wait to see you guys tomorrow. Have a great day.